first mover advantage. As you guys could see, this is the game in which there are two players, player 1 and player 2. Player 1 has two choices, X and Y, and player 2 also has two choices, A and B. Conditional on whether player 1 has chosen X or Y. Player 1 moves first and then player 2 moves. All of this could be easily seen from this particular game. And these are the payoffs. The first payoff is for the player who's first payoff is for player 1 and the second payoff is for player 2. Well, if you look at it, then using the backward induction equilibrium, so this is the one sub game, this is the another sub game, and then you have the entire sub game, which is the game itself. So this guy, so the first sub game, so out of these two, what will 2 decide? He will compare the payoff this and this. So he will definitely choose this. That means he will choose B. If he is at this node, he has to make a decision between A and B. He has to compare this payoff and this payoff. So he'll choose this payoff. That means A. Now the game is reducible because you do not have to worry about these redundant options. You just have to worry about these options. So player 1 has these two options, out of which player 1 compares this and this. So that is 4 and 3. So he will definitely choose this. And this he is getting by choosing X. Okay. So 4-4 is the equilibrium outcome or equilibrium payoff which player 1 and player 2 are getting in this. Now, in this recording, what we are going to do is that we will flip the moves of the players. So now player 2 is going to play first, and then seeing his choices or observing his choices, player 1 is going to move. Now, having seen this, so player 2 is going to move first. Here, he has two choices, A and B. Player 1 comes then after observing whether player 2 has moved A or B. Player 1 has two choices, either to move X or Y. Now, how will you write the payoffs? Just think about it. Player 2 moves A when player 1 moves X. Okay, so this is that same payoff. 2-2. Player 2's choice is A and player 1's choice is Y. Player 2's choice is A and player 1's choice is Y, which is 3-5. Player 2's choice is B and player 1 choice is X. Player 2's choice is B and player 1's choice is X. So which is this 4-4. Player 2's choice is B and player 1's choice is Y, which is this 5-3. So you have these payoffs now. Now again, there are three games. There are three subgames. This is subgame 1, this is subgame 2, and the entire game subgame 3. In the first subgame, using backward induction equilibrium, player 1 is at the decision mode. So player 1 is going to compare this and this. So player 1 is definitely going to choose this then. Choosing this means he's choosing Y. Okay. Now see the second subgame. Player 1 has to make a choice between 4 and 5 here. Okay. So he will definitely choose 5. that would mean he is choosing Y again. Now comes player 2. So he knows this, that player 1 is going to choose Y. You don't have to worry about these two redundant strategies. Now player 2's choices are 5 and 3. He has to compare between 5 and 3's payoff. So he will definitely pick up 5. That would mean he will pick up A. Now if you compare it, when player 1 was moving first, the payoffs were 4-4. Okay. Now when player 2 is moving first, the payoffs are 3-5. So the moment player 2 has moved first, there is an obvious increase. I know I should not be using the term obvious. That means there is an increase in the payoff from 4 to 5. Okay.